So this one, again, we're solving systems still. That's all of chapter 4 is just solving systems. So it all is going to look the same. Solving systems by the elimination method. When we use elimination, what we're going to do is add the two equations together so that one of the variables will go away. One of the variables will cancel out. Just like what we did with substitution, we replaced one of the variables, so there was only one variable left. Here we're going to cancel one of them out, so there's only one variable left. Okay? Now this is all based on this piece of information. And let me see if I can think of a good way to explain this. Let's say that I have 4 piles of money. They're going to be small piles of money because I don't have that much money. But in one of the piles of money, I have 4 quarters. In another pile of money, I have 10 dimes. And is everybody okay that 4 quarters is equal to 10 dimes when we talk about value? Okay? No, you don't think so? In another pile, I have, let's just say, 5 dollar coins. My kids like those. They like to have dollar coins. But we have 5 dollar coins. And then, whoops, we don't know they're equal yet. And this other side, we have, let's see, 50 dimes. And I'll just assure you, those are also equal, right? So what would happen if I took these 2 piles and put them together? And then I took these 2 piles and put them together. The total value over here would be $6, right? $1 here and then 5 more dollars here. So $6. The total value here would be $1 plus 5 more dollars. It would also be $6, right? Mm-hmm. So if you've got 2 things that are equal and 2 other things that are equal, and you add them together, the results are going to be equal. Does that make sense? Yep. And that's what this whole method, the elimination method, is based on. We're going to be adding 2 things together that are equal, and so the results are going to be equal also. Okay? So now that we've talked about money for long enough, let's move on to some algebra math. Okay. So we're going to solve this one using elimination. Now, this one's already set up for us. Remember how I started with a really easy substitution one last time? It was already x equals 5 and we were already done. This one's already set up for us so that if we add these 2 together, what's going to happen? Cancel y. These y's are going to cancel out because they're opposites, right? Does that make sense? Mm-hmm. So we're going to add these together. We're going to get 8x. This is going to cancel out to be 0. And then this is going to be negative 16. So in other words, you see how that's set up kind of like my money example? This was equal to 8. This was equal to negative 24. If I add them together, the results are still equal. And do you see how we get an equation we can solve very quickly here? What do we do to solve this?
Divide by 8.
Divide by 8. And we find out that x equals negative 2. Okay? Now, once we know that x equals negative 2, what do you think we might want to do with this?
Substitute.
Yeah, we're going to substitute it back in to either one of the equations. It doesn't matter which one. Last time we kind of had a pattern. We always put it into that other equation. Here, we can put it into either equation. So again, I would pick the one that maybe has the smaller numbers. I'd maybe pick the top one. So we're going to have 3 times x minus 4y equals 8. And we just figured out that x is negative 2. So that means this is negative 6 minus 4y equals 8. And what do we do to solve for y?
Add 6.
Add 6 is our first step to cancel that out. So negative 4y equals 14.
Divide by negative 4.
Divide by negative 4. Now this is the first one that we've really seen like this. We get negative 14 over 4. If we reduce that, it's negative 7 over 2. It doesn't come out evenly. And that's okay, but this is one of those that we wouldn't want to try and have to graph because it doesn't come out nicely. So what is our answer? -2, comma, -7/2. And again, if we want to go back and check that, here's what this would say. We should check it to make sure it makes both equations true. This would be -6. A negative times a -7/2 times a -4 is going to be +14. And that is a true statement. -6 plus 14
You
is
have to reduce.
8.
You still get the same answer if you don't reduce.
Yes, but when you give your answer, you do want to reduce.
Okay.
We always want to reduce our fractions if we can. If you want to change it into -3.5, that's fine too. That's what that equals. But you can just leave it like this also. For this one, we'd have -10, and this would be -14, and that also is a true statement. -10 minus 14 is -24. So you can still check, and with a calculator, that's not too hard to do. You don't even have to do it in your head. You can do it with a calculator and get your answer. Okay? So, but this is the key right here that we're going for. When we do this, before you can add these together, you have to make sure that either the x's or the y's will cancel out. So they have to be opposites. If they don't, there's no reason to add them together because you're still going to have two variables.
So if they don't, then you would just do substitution?
You could, or I'm going to show you what to do if they don't.
Okay.
Okay? Because a lot of times, like this, they don't.
Yeah.
Okay, so this time you'll see we can't just add these together because nothing's going to cancel out, right? We would get like -4x and we get 8y and we get 24. So nothing cancels out. Not helpful. Now, you could use substitution, but all these are going to get really messy with fractions if you tried it, in this case, if you look at them. So here's what we do. Do you remember how in math, and we've done this a lot, how we can multiply both sides of an equation by the same value?
Mm-hmm.
Or divide both sides of an equation by the same value, or anything else? But here we're going to multiply. We're going to focus on multiplying. Are there any of these numbers that we could turn into, like, could I turn, and I usually start with the smaller ones, could I turn 2x into 6x so that it would cancel, or turn 3y into a 5y by multiplication so that it could cancel?
2 by 6.
I could change a 2x into a 6x so that it would cancel, right?
Mm.
How would I do that?
Multiply 3.
Multiply by 3. So what we're going to do, again, we got to do the same thing to both sides of our equation. We would multiply this side of the equation by 3, and we would multiply this side of the equation by 3. Kind of like if we were solving an equation, but we're not solving it yet. Okay? We're just adjusting the numbers so that they'll cancel out for us. So I'm just going to copy down the top equation. I'm not going to do anything to it. I'm just going to copy it down. Equals 22. And on the bottom equation, notice we have to distribute. So 6x. And then this will be 9y. And then this 3 times 2 over here will be 6. So does everybody understand what we just did? Multiplying by 3. And the reason we did it is because now, look at these two. Now when we add, now they will cancel out, right?
Oh, hold on just a second.
Okay.
You're multiplying 3 times 2. No, okay, the top one.
Are
3
we-
times 6.
No, we're down here on the bottom one. We didn't do anything with the top one. We left it alone.
I'm using the top one.
Okay. Yeah. We didn't touch the top one at all because that one we don't need to worry about because it's already what we want. Sometimes we will have to do something with both, but in this case, we just had to do one. Okay. Okay, good. So now, again, our goal was to get something to match up as opposites, right? And once they match up as opposites, now we can add them together. So what happens with these x's? They're going to cancel. That was the whole point of doing that. What do we get for the y's? 14y. And on this side, there's our equal sign, and then 28. Okay. What do we have to do to finish solving for the y? Divide by 14. So y equals 2. So if you're thinking about your answer, ordered pair, the y value is a 2. What do you think we should do with the 2? Substitution, right? Plug it in. And which of these two equations do you think would be the easier one to plug it into?
2x.
Yeah, I would go back to the original equations just because that was before we did anything with them. And I would use the bottom one just because the numbers are smaller, right? So 2x plus 3 times y equals 2. And we just figured out that y was equal to 2. So 2x plus 6 equals 2. Then what do we do after that? Subtract 6. 2x equals -4. And I divide by 2. X equals -2. So our ordered pair, -2, 2. If we plug that back in to check it, this makes this a 12 and this makes this a 10. That is true. This one becomes a -4. This one becomes a 6, and that is also true. So then we know for sure that our answer, -2, 2, is the correct answer. Okay, so
This one's a little more.
this one is, you got to be careful with this one. But actually, once you learn it, it becomes easier, I think. But you got to learn it. So if you don't get really comfortable with it, then you just maybe stay with the substitution. Okay, but again, remember what we have to have is we have to have these to be opposites before we can do the elimination part, before we can add them. Okay. All right, let's try another one. So this time again, what I like to do is look at my smaller numbers. So is there any way that I can multiply really easily to turn a 2 into a 3x? No. How about to turn a 6y into a 9y? No. So here's the next thing. Sometimes we can't just, so sometimes it's not ready right away. Sometimes we have to multiply one of the equations. In this case, if we're going to use elimination, we have to multiply both equations by something. So let's think to ourselves, and again, I like to stay with the smaller numbers. Is there anything that I can use multiplication on and turn both the 2x and the 3x into some other number?
Yeah.
What?
3.
6. Does it has to be the same number for both?
We want to turn them both into the same number.
But like you have to use the same number.
Not when you multiply. You can multiply by whatever you want. But what could we turn both of these into?
6.
That's 6.
We could turn them both into a 6, right?
Mm-hmm.
What would we have to multiply the top equation by? And I'm just going to put one big parentheses here.
2
Times 2.
Multiply it by 2. And what about the bottom equation?
times 3.
Times 3. Now there's one other thing we have to make sure of. We need them to be opposites, right? Because that would make them both 6s. If we add the 6s, we get 12.
Mm-hmm.
So I want to wait till they're done conversing. So, and it's okay. I just want to make sure you don't miss this because this can be important. So if we did this exactly the way it's written, I would get 6x and 6x, right? If I add 6x plus 6x, they won't cancel out.
Mm-hmm.
So I need one of them to be a
Negative.
-6x. Does that make sense?
Mm-hmm.
So I just need to make one of these, either the 2 up here or the 3 down here. I need to make it a negative.
Mm-hmm.
Multiply both sides by a negative number. Which one do you want to do? The 2? Make this one a negative. Okay. She stepped out in courage and said, let's just make the 2 negative. All right.
Okay.
So now we multiply. So this one will become -2 times the 3x is going to be -6x. -2 times the 6y is going to be -12y, equal sign, and -2 times the -9 is going to be +18. Does that make sense to everyone? Okay, now we're going to do the bottom one. So we're going to multiply the 3 times the 2, and we get positive 6x. We're going to multiply the 3 times the 9y, and we're going to get 27y. Then our equal sign. We're going to multiply 3 times negative 26.
Negative 78.
Negative 78. Okay. So what you missed was sometimes we have to multiply both equations. And what we did is we looked at, okay, I can turn this into a 6x and I can turn this into a 6x by multiplying by a 2 and a 3. And the other thing was we need to make sure there's still opposite signs, so we had to make one of them a negative. So we chose the top one was a negative. Concha chose it. She said, make the top one negative. So we did.
What
Now-
about if we multiply with, instead of -2, we multiply with 2, and then instead of add, can we do subtract?
You can. I don't teach it that way just because people, what I've found is people start subtracting, but by the time they get to the end, they stop subtracting, they start adding again. So I just set it up so we always do addition. But yes, if you know, if that's the way you learned it, that's fine. Now, when we look at this,
So 6x.
the 6x's will cancel. And we're going to have positive 15y, and this is going to be negative 60. How do we solve for the y? Divide by 15. And what do we get for our value for y? It's going to be a negative because you got it, and it's a 4. That's right. So something comma -4 is going to be our answer. Now, what are we going to do with that -4?
Substitute.
Substitute it back in. So I'm going to erase all these marks over here. Which one would you like to substitute it in to, the top one or the bottom one? Bottom. So that means we have, so we're going to put it in over here. 2x plus 9 times y, which we just figured out is -4, equals -26. So that's 2x minus 36 equals -26. And how do we continue solving for the x? Add 36. So that cancels out to be 2x equals 10.
No, I did it wrong.
And then divide by 2. We get x equals 5. So we believe that our answer should be 5 comma -20. Or sorry, 5 comma -4. That's not a 20. 5 comma -4. If we check our answers, this would be 15 minus 24. And that is true. That equals -9. This would be 10 minus 36. 36 equals -26. And that is correct also. So again, especially when you're getting 2 different answers, x and y, I would try to go back and check these just to make sure that you're getting the right answers. That way you don't plug it into the computer and then it says wrong. You can already know ahead of time if you're right or wrong, and you can put it in with confidence and say, I know this is the right answer. 10 out of 10 for me on all of these.
I actually, on our test for the second, I had done it, like I finished it all, and then I was like, okay, I'm
I'm going
done.
to check them.
And then I started checking, and I find out that I had like
A
2
couple
wrong.
wrong?
Yeah,
Okay.
I was like, oh, shoot.
So again, sometimes we have to change both equations, okay? And that's as hard as it gets. Sometimes you have to change both equations, okay? So here's our elimination process. First thing, line up the variables and the constants. And they've all been lined up so far, right? We had the x's lined up, and then the y's lined up, and then the equal signs lined up, and then the constants on the other side. You always want to set it up that way if you're going to do elimination. Don't let anything get out of line. Otherwise, it's all messy. Then, if you need to, multiply to get opposites. Either x's be opposites or the y's be opposites. Okay, sometimes you don't need to multiply, but if you need to, you multiply to get opposites. Then we add our 2 equations, solve what we get, and then plug it back in and solve for the other one. Okay? And that's, like I said, that's as hard as it gets. It's always the same steps. Substitution, always the same steps, right? Elimination, it's really always the same steps. Some are easier and some are harder just because of the numbers, but they're always the same steps. So let's do this one. And which variable, there's nothing obviously that's going to cancel right away, correct?
Mhm.
Can't just add them because nothing's going to cancel out. So like I said, I usually start with the small and I say, can I turn the 2x into a 6x so that it will cancel?
Mhm.
Yeah. What do I need to multiply by to make that happen?
3.
A positive 3,
Mhm.
right? Because I want them to be opposite, so I'm going to multiply by 3. And like I said, I'm just going to put parentheses around the whole thing, and we're going to multiply everything by, everything by 3. So when we do that, we're going to get 6x. We're going to get negative 15y. We have our equal sign, and then we're going to get 9.
Mhm.
Okay, now on the bottom, we're just going to copy it down. So negative 6x plus 15y equals negative 9. So we match these up. So when we add them together, what will happen with the x's? They cancel out. Uh-oh, what happens with the y's?
They cancel out.
They also cancel out, which means on this side we have 0. There's nothing left over there, right?
Mhm.
Then we have our equal sign, and what happens on the other side?
Cancel.
It cancels out also, so we have 0. Something like this happened with substitution, right? All the variables go away, then we have 2 options. What are the 2 options? It's either always true or always false, and this one is this true or false?
True.
It's true. So what did that mean?
Infinite. So
Infinitely many solutions. Oops, infinitely many solutions. If your variables ever go away completely, as long as you have a variable left, you still solve. But if your variables go away completely, like it did in substitution or like it did just right here, that means it's one of those special cases. It's either infinitely many solutions or no solutions. Okay? And it all depends on if your statement is true or if your statement is false.
this one will mean that the line is a 1 line.
These are actually both the same line. So if we wanted to do it like we did on the last one, we would just take one of these and solve it for y. I'm going to double check. I don't think you have to do that on that, but I do want to double check. I'll try and do that during our break after this lesson is over. Okay? Does that make sense? Since you're left with a true statement, infinitely many solutions.
Mhm.
They're actually the same line. So if you were graphing them, you just put one line would be right on top of the other one. Okay? Let's try this one. So again, can I turn the 4 into a 6?
No.
Can I turn the 6 into a 9?
Mhm.
No. So I'm going to have to change them both, right?
Mhm.
And so I'd probably work with the smaller ones. Can I turn the 4 and the 6 both into some number?
Mhm.
Both into 12, right?
Mhm.
How could I turn this 4 into a 12?
3.
Multiply by 3. How do I turn the 6 into a 12?
2.
Multiply by 2. Now, what's our one other thing we have to make sure of?
Negative.
Yeah, right now they'd both be positive 12, so they wouldn't cancel out. So I need to make sure one of them is a negative. So which one do you want to make negative?
2.
The 2?
Mhm.
Okay. All right. So multiply here, we get
Well,
12x. Here we get
9.
minus 18y equal sign, and here we get 24. Okay. Here we get minus 12x, which is good. We want them to cancel. We get positive 18y equals negative 30. So again, we match these up. We know that we can add now because these are going to cancel. They're opposites. What happens with the y's? They cancel again. So we're left with 0 on this side. But what happens over on the other side?
Negative 30.
Not negative
I mean-
30. Negative
30 minus
6.
Negative 6.
Now, what does that tell us? All the variables are gone.
False.
It's a false statement. All the variables are gone and it's a false statement. So that tells us no solution. Okay, does that make sense?
Then parallel line.
And those would be parallel lines if we were graphing
So
them.
you want us to write false, no solution?
You don't have to write the false, just no solution is enough. I'm just emphasizing the reason we know it's no solution is because it's a false statement. 0 does not equal -6. At least not in this world. Okay? Does that make sense?
Mhm.
Okay. And that's the end. So like I said, 4.2 and 4.3, there are 9 problems, and you are allowed, probably follow the directions on what they say, but I will tell you on the test, as far as doing them on the homework, but on the test, I don't specify you have to do this by substitution or you have to do this by elimination. But here's what I'll tell you. Sometimes it's easier to do certain problems with substitution. For instance, if I saw a system and one of the equations was x equals 5y plus 3, this is set up for substitution right away, right? I know that x equals 5y plus 3. I'll just substitute. Does that make sense?
Yes.
Because it's already ready to go. If I see that the equations look like this, 2x minus 5y equals 10, and
Negative.
-3x plus 14y equals 17. If I see those, I'm going to elimination. Okay. First of all, because I like elimination better, but secondly, because these numbers aren't going to come out nicely if I tried to substitute. Right? This would be the one I'd probably go for, but I get fractions and fractions. Right? And you can do it with fractions. It's just more difficult because people don't necessarily enjoy fractions that
So
much.
we get to decide which one we want
You
to
will,
use.
on the test, you'll get to decide which one you want to use.
Okay.